Question 2 of this exercise is actually quite interesting. It says that we know that the decimal representation of 1 by 7 is this recurring decimal 0.142857, where there's a bar on 142857, which means that this block of digits repeats. So this is a non-terminating recurring decimal. Using this, can you predict the decimal expansions of 2 by 7, 3 by 7, 4 by 7, 5 by 7, 6 by 7 without actually carrying out the long division process? So how can you do this? And the hint says study the remainders while finding the value of 1 by 7 carefully. So let's start with doing long division to find out 1 by 7 first. Okay, so to find out 1 by 7, the divisor is 7 and the dividend is 1. So because 1 is less than 7, we put a decimal point and we add a 0 here. So now the first multiplier will be 1. So this gives us the term 7 and leaves a remainder of 3. Now the next dividend is therefore 30. So the next multiplier is 4. Now 7 times 4 is 28 and this leaves a remainder of 2. So the next dividend is 20 and the next multiplier is 2. And this generates 14, which means that the remainder is 6. So the next dividend is 60, which means that the next multiplier will be 8 because 7 times 8 is 56. Now this leaves a remainder of 4. So the next dividend is 40. Now the next multiplier will therefore be 5 because 7 times 5 is 35. And now this leaves a remainder of 5. So the next dividend is 50, which means that the next multiplier will be 7 because 7 times 7 is 49. Now 50 minus 49 is 1. The remainder is 1, which takes us back to the first stage of the division process, because the next dividend will be 1 added with a 0, appended by a 0, so 10. So again, the next term in the quotient will be the next digit in the quotient will be 1 again. So from this point onward, the block of digits in the quotient will start to repeat. So this block of digits 142857, this will start to repeat, and therefore we see that 1 by 7 is actually 0.142857 with a bar on this block of 6 digits because this block will keep on repeating. Now, using this long division, how can we determine the decimal representation of 2 by 7? So how can we determine the decimal representation of 2 by 7? So well, in 2 by 7, the dividend in the first step has a 2, not a 1. So look carefully at the long division process of 1 by 7. Where in this long division process, at what stage was the remainder equal to 2? It was actually at this stage here when the remainder was equal to 2. And in the long division of 2 by 7, this will actually be the first stage or first step. And corresponding to this stage, the multiplier in 1 by 7 was 2 because 7 times 2 gave us 14. So the first multiplier in 2 by 7, the first digit of the quotient after the decimal point, will actually be 2. In other words, 2 by 7 will start off as 0.2. Now here's the interesting bit. The long division for 2 by 7 will now follow the exact cycle as the long division of 1 by 7 starting from this stage. So the next remainder in the long division of 2 by 7 will be 6, which means that the next multiplier in 2 by 7 will be 8. In other words, the next digit in 2 by 7 will be 8. This cycle will continue and the subsequent digits of 2 by 7 can now be just found out by looking at the long division of 1 by 7. So for the remainder 4, the digit will be 5, which means that the next digit in the quotient of 2 by 7 will be 5. Then the next remainder will be 5, which means that the next digit in the quotient will be 7. The next multiplier will be 7. So the next digit in the quotient will be 7. The next remainder will be 1, which was actually the first step in 1 by 7. So the next multiplier or the next digit of the quotient will actually be 1. And then for the remainder 3, the multiplier will be 4. So the next digit in the quotient will be 4. Now we are back to the remainder 2 once again, which is the first dividend in 2 by 7. So from this point onward, the decimal representation of 2 by 7 will start repeating. This means that 2 by 7 will actually consist of the block of digits 2, 8, 5, 7, 1, 4 repeating, or in other words, 2 by 7 is 0.285714 with this bar on this block of 6 digits. Note how 285714 is actually a cyclic rearrangement of 142857. Now we can similarly find out 3 by 7. In 3 by 7, the dividend in the first step is 3, which corresponds to this stage in the long division process of 1 by 7 when the remainder was 3, and corresponding to this stage the multiplier was 4. So the decimal expansion of 3 by 7 will start off from 0.4 and it will follow this same cycle of 1 by 7 all over again. So the subsequent digits of 3 by 7 will be, so what comes after 4? So after 4 we have 2, so we'll have 2 here. Then we have 8, so we'll have 8. Then we have, so we had 8, then we have 5, so we'll have 5 here. Then we have 7, so we'll have 7, and finally we'll have 1, which is the 6th digit of the cycle, so we'll have 1, and then this block of digits will start to repeat. So 3 by 7 is 0.428571 with a bar on this block of 6 digits. Similarly, for 4 by 7, the dividend in the first step is 4, which corresponds to this stage of the long division process of 1 by 7 when the remainder was 4, and corresponding to this stage the multiplier was 5. So the decimal expansion of 4 by 7 will start off from 0.5 and then it will follow the same cycle of digits. So after 5 we will have 7, then we'll have 1, and then we'll have 4, 2 and 8. So 4 by 7 is 0.571428 with a bar on this block of 6 digits. Similarly, for 5 by 7 will start off from the stage when the remainder was 5, which is actually this stage, and corresponding to this stage the multiplier was 7. So the first digit in the expansion of 5 by 7 will be 7, and then the same cycle of digits will continue. So we will have 7, 1, 4, 2, 8, 5, and with a bar on this block of 6 digits. And finally for 6 by 7, we'll have to start off from the stage in 1 by 7 where the remainder was 6, which is actually this stage, and corresponding to this stage the multiplier was 8, the digit was 8. So 6 by 7 will start off from 0.8, and then the same sequence, the same cycle of digits will continue. So we will have 5, 7, 1, 4, 2. So, and with a bar on this block of 6 digits. So just from the cyclic pattern in the long division of 1 by 7, we can figure out the decimal expansions of 2 by 7, 3 by 7, 4 by 7, 5 by 7 and 6 by 7. I find this concept really awesome, and in fact if you want to delve deeper into this, do some research online on cyclic numbers. the number 142857, this block of 6 digits, this number is which is the repeating part of 1 by 7, is actually one of the most well-known cyclic numbers. And with that, we complete our discussion of this question.
Hi students, being good at math is super important because it helps you do well at school, but more importantly, it opens the doors for you to the most awesome careers of the future. Having taught thousands of students, I can confidently say that every student can really excel at math, including you. So I've created something special to help you become a master of math. Go to qmat.com/leap to find out more. I'll see you there.